In the previous tutorial, I've talked to you about the byte ordering. In this video, we're going to proceed our work talking about DGRAM sockets, and which they are also known as UDP sockets. So in the previous tutorial, before previous tutorial, we've talked about the socket stream socket, and we've explored TCP socket, and I've showed you how to generate an HTTP request, and we've created a program, our first program called banner grabbing. So now let's explore UDP socket. UDP stands for User Datagram Protocol. And as I told you before, UDP is a non-reliable protocol since it's not using the three-way handshake. Unfortunately, or not unfortunately, because it has its own features or advantages. As I told you before, actually using we've talked about stream socket in details. Now we're going to be talking about the right corner here, the DGRAM socket. So the first thing we're going to do is to create a socket instance, a server socket instance, and a client socket instance. And we've got here only the bind method, okay? The bind method. And as I told you before, the bind method, it's gonna actually assign an IP address to the socket, okay? So it's gonna tell the socket which interface to be listened on, okay? And as you can see here, there is no listen function and accept function. And I've told you before that the accept function is responsible of the three-way handshake. For example, the connect and as well as the accept actually methods in this place here where the three-way handshake happens. Okay, so since UDP doesn't understand the three-way handshake, actually there is no listen and accept methods. Okay, so we are going to bind the socket, and the reason why we're binding in the client side, because binding on the client side allows us to make changes to the source port number in the UDP header, on the transport layer. Okay, so for example, let's assume that you have a DHCP server to deal with, and you want to send a DHCP discover to that server. The bootp client or the DH client has you or uses a port number of 68. Okay, so in this case, if you're not gonna bind to the address, a random address or a random source port number is would be picked up. Okay, would be picked up, and in order to make changes to the source port number, actually you can go ahead and make changes to it using the bind method. Okay, and you are going to send the data to, and the send to, it's not like the send method, and the send method would accept only the data to be sent, but the send to requires two parameters. The first parameter is the packet itself, and the second parameter is a tuple made up of the source, the destination IP address, and the destination port number. The receive from, as I told you before in the tutorial grabbing banner grabbing tool, I've told you that the receive from returns a tuple, and the tuple actually is made up of the data as the first element, and the server IP address or the other peer IP address as the second element. And the close, as you can see here, it is used to reset the connection using a reset ACK flag set reset ACK flags. Okay, or I'm not sure, we are going to close the connection and see how it is used in UDP. So let's go ahead and uh, clean up this stuff and start up sniffing, and I've filtered out RIP, the routing information protocol. So as you can see here, this is the how a RIP version 1 is used. We are going to generate a RIP version 1 header and send it over the network. So in order to, we are going to import the socket first, and I am going to create a UDP socket here, and socket.af inet sock diagram. Okay, so now we've got a UDP socket instance. Okay, so now we can actually go ahead and define a rip method here, and we are going to generate it ourselves. Okay, so the first thing is the command. The command is one because we are going to send a request. um, so the second one is the version. Let's say var is equal to 1. We are going to use rip version 1. The other field is reserved, so reserve is equal to 0. The rip table is made up of multiple fields. As you can see here, we have the address family. It is 2, IPv4, or you can actually use the socket.af inet. So I must answer the phone. Give me a minute. So we're back. So as you can see here, the address family is 2. So we can actually make it as an integer 2 of 2, or call the socket AFINet. And next we've got a reserve bit of 0, and the IPv4 must be here converted to the network byte ordering. And I've told you before that there is a method called inet to convert internet addresses from a address to network byte order and network byte order to address. So in this case we have an address and we are going to convert it into the network byte ordering. So let's put up an IP address, and reserve 2 is equal to 0, and we've got a reserve 3 which is set to 0 as well, and the metric is equal to 1. So now we are going to generate the rip header, and we are going to use the struct module to pack data. So we've talked about packing data, and we haven't talked about unpacking. So packing data is taking up the data and convert it into the appropriate format. So here we are going to use the network byte ordering. Okay, so we've got a B as the command, and the version is B, the reserved is H, and the address family is H, the reserved is H, the IPv4 is 4S, and we've got another L because the reserve is an integer, another L and another L. So BBHH, so B, B and H, okay, BBH, and we've got another two H's, HH, 4S, LLL. Okay, so now we can pass in the command. Okay, we can pass the version, we can pass the reserved, we can pass the AF, we can pass the res1, we can pass the IP, we can pass the res2, we can pass the res3, and then the metric. Not Patrick, but metric. I don't know Patrick. Metric. Okay, I've made a mistake here. And we can actually return the rip header. So if we import the struct module, okay, and call the rip method, as you can see here, we've got a packet here. So the packet is equal to rip. So we've got a packet here. So we've got a UDP socket. We are going to bind our address. We're going to bind it to our local address, which is 91, and the rep version 1 port number, which is 520. Cannot assign request address. The reason is we've got a wrong IP address. Okay, now we can actually send data to the packet, and we've got a tuple here. This is the IP address we are interested in sending the packet, and the source port number or destination port number is 520. Okay, so let's send the packet. It's 24 byte. If we go here, as you can see here, indeed we've received a RIP information protocol, routing information protocol. The command is request, the version is v1, the family is IP, and the metric is 1. And indeed we've been able to pick up a source port number as 520 or 520. So that's all for this video. See you next time.